I just have to record. Okay, so let's say this had components V1, V2. So what are some different ways you think then that we could, well, first of all, how would we find V1 and V2 if we knew this and we knew theta? Think of a triangle. If this was a triangle, okay, what's this piece of the triangle? Which side? The hypotenuse. If I wanted to find the adjacent piece, couldn't I say the cosine of theta, you following this, is equal to V1 over the magnitude. So if you solved that for V1, what we would get is you can take the magnitude of a vector and multiply by the cosine of the angle to find the first component if you did not know it. What could you use for the second component then? The sine. So if I knew the magnitude and the angle, you could take the magnitude times the sine of the angle. Okay, now, you see that for direction angles, that formula is on there. What is not on there, and what we're going to add in a second, is how you can find theta. There's different ways that you can find theta. You could use tangent inverse. You could use sine inverse. You could use cosine inverse. So one way, if we knew V2 and V1, is we could say that theta is the tan inverse. Remember, because doesn't the tan inverse give us an angle? But what would we need? Which two pieces? Opposite, which is this V2 over V1. Now we have to be a little bit careful because there are two spots where the tangent could equal that. Like if this was a negative over negative, it would still give me this angle. So I'm going to put a little star here. You might need to add 180. Now, I think our book gives us the formula to find theta. They take the cosine inverse. They take the cosine inverse of V1 over the magnitude. Would that work as well? Yeah. So really, any inverse trig function would work depending on what you're given. So if you're given these two pieces and you don't need to find the magnitude, then I would use tan inverse. If you're given the magnitude and these components, you could use cosine inverse or sine inverse. Does that make sense? Okay, so there's multiple ways that you can find that angle, but let's add that to your formula sheet. So to find theta, it's going to be the tan inverse of V1 over V2. And I'll add that other one. Or cosine inverse of V1 over the magnitude. For Pete's sake, it is. Yes. Did I write it wrong on the other one? This should be V2 over V1 because tangent is opposite over adjacent. Okay. So let's use this concept and we'll do two different things. The first one, I ask you to find the magnitude and direction angle. So we're going to find theta of negative 3, 1. So let's just draw negative 3, 1 so we know what it looks like. And so what we're trying to find here is theta is the angle in standard position, we would call that, so from the x-axis over here. So this is going to be what kind of angle? Greater than 90, right? Okay. All right, so let's first do the magnitude. How would I find the magnitude? So, yep, the square root of -3, or -3 squared plus 1 squared, take the square root, so it's root 10, right? Okay, so then for theta, I'm going to show you with tan inverse. We can take the tangent inverse of V2 over V1, but remember we might need to add 180 because the tan inverse is only going to output one angle, kind of like that ambiguous case of the sine. Remember how it only gave us one angle and sometimes we need to find another. The way we would find the other in this case is to add 180 if we need to. So we're going to want our calculators in degree mode. And I get -18 degrees. -18 degrees is down here. See that? Because it's going down 18 degrees. So that's not the angle I want. So I'm going to just add 180 to that. You're going to have to look and see. Sometimes you're in the right spot, sometimes you have to add 180. So I add 180 to that, and what do I get? Depending on how you rounded, yeah. Okay. Hopefully this looks to you like a 162 degree angle. Okay. So I didn't have a picture that I could put on here, so we're going to draw our picture in. Alright, so let's say I gave you a vector and I did not know the components of that vector, but I told you that it had a magnitude of 6, and I also told you that this angle was 115 degrees. And I want us to find the component. Okay, so up here I wrote if we wanted to find the component and we knew the magnitude and we knew the angle, this is how we're going to do it. So to find the first component, I'm going to take the magnitude, which is 6, times cosine of the angle. I'll punch that in my calculator in a second. And then I'm going to take the magnitude times the sine of the angle. And then we're going to just double check that it looks like that ordered pair is where the terminal point is. Alright, so can you do that for me? I'll just round to the nearest tenth. So -2.5 and 5.4, does that look like that could be the terminal points then? Does that make sense? Negative up. Okay. Good. Questions so far? Alrighty. Then, so yesterday I talked about how vectors really, they're an application thing. That's really what their most useful purpose is. And so in navigation, you would be dealing with vectors and angles and magnitudes. So just some reminders. When you see a bearing, do you guys remember what that means? That means it's clockwise. That angle is clockwise from the north, because a bearing is a compass reading. Now, you can just draw it and figure out what the angle is with the x-axis, but if you're given a bearing, to find theta, a formula that will always work is 90 minus the bearing. Now, it might give you a negative angle, but that's okay if we're using sines and cosines, because it will still output the correct value. Okay, so let's take a look at this one then. So a jet is flying on a bearing of 65 degrees, so we're going to have to figure out what theta is at 500 miles per hour. So let's draw a north, and if I would try to go 65 degrees, I don't know how far 65 is. We'll say it's that far from the north. Then this would be my plane, and it's flying at 500 miles per hour. Okay, to use our formula though, we have to figure out theta, and theta is the angle from standard position or the x-axis. By the way, the speed of a vector is its magnitude. Okay, so 500 is its magnitude. All right, so what is theta? So since I asked for the component form, I'm going to use that same formula that I did before, that you can find the component form by taking the magnitude times the cosine of the angle, and the magnitude times the sine of the angle. So, what was the magnitude again? So we would do 500 times cosine of 25, and then 500 times sine of 25. All right, would you do that for me, please? What do we get? 453.2. And then did you get 211.3 when you typed it in? Okay, and so sometimes basically this is like the speed the plane is going this direction to the east. You could break it down into two components. It's like if I had something pushing it this direction with that magnitude and that direction with this magnitude, that would make the plane go that direction. That's what a vector means. Okay, how are we doing so far? Okay, that's fine. Now let's do something a little different.
Oh, yeah.
Okay. It is. And so you got to just kind of look big picture. If you have two things that are acting, this is what we talked about yesterday. If you have two vectors acting on it, the result is just the sum of those two vectors. So if I have a plane and then a wind, I'm going to find the components of the plane, and I'm going to find the components of the wind, and the result is just going to be those two things added together, because those are the two things acting. You have the plane, what it's supposed to be doing, and then the wind blowing it possibly off course. Okay, so Let's take a look at the plane first. So a pilot leaves San Francisco flying due east. Did I tell you? I didn't. I have to tell you yeah, I should have told you. A pilot leaves San Francisco flying due east, and I have to tell you a magnitude. Let's say he leaves at 450 miles per hour, okay? You couldn't do it unless I gave you. Alright, so here's the plane. And the plane is going, I need a different color. Due east, which is just here. Okay. Now, technically, this angle is 0, right? Because it's not going anywhere. Agreed? So if I said, okay, the components would be 450 times cosine of 0, and let's say you got confused. All right. 450 times cosine of 0. Oh, that's just 450. And then 450 times sine of 0. Oh, that's just 0. But hopefully we don't even need to get there, because wouldn't the components of this point be 450, 0? Couldn't we figure that out without? Okay. But if you were given a little different angle, you would use our formula, magnitude times cosine of the angle, magnitude times sine of the angle. So that's the plane vector. I didn't even give you this, did I? I don't know why not. There's a 65 mile per hour wind, and that, let's say, has a bearing of 60 degrees. I think there was a picture that was with this problem, and I forgot to put the picture on. I think that's fine. So here's my wind, 65 miles per hour. The 65 represents the what? Magnitude. Okay. The bearing of 60 means I'm going 60 degrees from the north. So this is my wind. Okay. Which means theta is what? 90 minus 60, or 30. Okay, so can you guys find the components then of that vector for me? Does that make sense with what you have? Okay. So if I wanted to know, well, I have to find the compass heading the pilot should follow. Let's just at least write the result, or the resultant vector. So I'm going to add these two things together, because this is what's happening. We have the plane, and then we have a wind pushing it off course. So the vector that the plane would actually be going would be 450 plus 56.3, which is 506.3, and then 0 plus 32.5. So just think of this. If I were to graph this, I hope that would make sense, because this is what the plane was doing, but that wind is pushing it slightly up, because it's going, if you were to graph 506 up 32, we don't have enough paper, but it would be slightly up off that course, correct? Okay. All right, so let's find then the compass heading. Compass heading is an angle, right? Do we know how to find theta if we're given a vector? Yes. How do we do that? So I'm going to find theta. Oops. And we'll say it's 4 degrees. So this is pushed 4 degrees off course. Okay, so what would be the compass reading then? 86. The compass reading is the bearing. The compass reading would be 86 degrees. Good. So that was one of the things I asked you to find. Now my guess is that this wind, because it's not going straight into the wind or anything, is not going to affect the speed of the plane that much. I don't think it's going to be very far off from 450. But if I wanted to find the ground speed of the plane, that would be the miles per hour of the plane. What do you think I would do? Find its magnitude. So let's see how far or how much that wind really changed that vector. So actually sped it up, which kind of makes sense, right? Because the plane, it was pushing it a little further, partly in that same direction that the plane was going. So the ground speed now of the plane is about 507 miles per hour. Who's ever been on a flight where like if I went to California once, well, more than once, where one direction, the time to get there, same plane, same speed the plane could go, was different than on the time back? Why do you think that is? Exactly. Especially like when you're flying, mostly winds come out of the west. And so if I was flying towards California, that west wind would slow us down going there, but speed us up going back. Does that kind of make sense?
Yeah. Are we supposed to find